you everybody for logging on tonight. It's very exciting to be presenting this webinar in collaboration with the Australian Energy Foundation. I would like to acknowledge the traditional custodians of the land on which we broadcast tonight, the Gadigal and Wangal peoples of the Eora Nation, and pay my respects to elders past, present and future, as well as all elders on the lands in which this broadcast is being watched. This is and will always be Aboriginal land. I'd also like to extend a welcome to Councillor Langford, who is in the audience tonight. Now, my name's Cribbo Ackerman and I am an engagement officer with the Green Living Centre. And our remit is to encourage, educate and assist local residents to adopt a low carbon lifestyle and more sustainability practices in your home and life. So to do that, we run workshops, webinars like this and other events. You can find us on Facebook and Instagram. We have a website and an e-newsletter. So feel free to check those things out and follow us. And you can also find all our events on Council's What's On and website. And talking about Council, I just want to say a few words about Council's work and commitments to zero emissions mobility. And Council has set ambitious targets to reduce community climate emissions by 75% by 2036 and to achieve net zero in council emissions by 2025. And the way to do that is set out through the integrated transport strategy and the climate and renewables strategy. And both these strategies actually include a road user or transport hierarchy, which moves from walking to driving. So it's just interesting to remember that driving a car is perhaps not the first option you could be thinking about. And we encourage you to think about other options. Council itself has already moved to hybrid passenger cars and is planning a staged transition to a fully electric fleet. Now, I'm going to hand over to Ken Welsh, Team Leader of Transport Planning, to say a few words.
Thanks, Cribbo, and thank you all for joining us. I'm the team lead for strategic transport planning, so my team prepare our various strategies and policies related to transport. And the electric vehicle encouragement strategy was one of our prime policies for this year. It was adopted by Council on the 12th of April. As a draft for exhibition, we're looking at preparing a draft that should be exhibited in July this year. And running parallel to that will be an expression of interest that we'll be putting at trying to encourage up to 3 charging providers to assist us in implementing a trial of public electric vehicle charging units, somewhere between 15 and 30 across the LGA over the next year or so, depending on what the expression of interest comes in at. So we're definitely heading the right direction, and we need your support to do this. Cribbo, I'll hand back to you.
Thanks so much, Ken. Looking forward to all those initiatives. I'm going to hand over now to Andrew Redaway, who is our presenter from the Australian Energy Foundation. Andrew is a senior consultant with the Australian Energy Foundation and has worked previously at Renew and the Australian Energy Market Operator. He's worked on detailed economic modelling of solar systems and efficient electric appliances. And his qualifications include solar installation training, certification as a passive house designer, in addition to a mechanical engineering degree. So over to you now, and thank you to Gus as well for making this all run very smoothly in the background.
Great, thanks a lot, Cribbo and Ken. So Australian Energy Foundation, so we're leading the way to an equitable zero carbon society. So we're a not-for-profit organisation and our work benefits all Australians. So as well as our other projects and services that we offer through councils, etc. We also run major projects which focus on vulnerable consumers and upgrading homes for energy efficiency, insulation, draft sealing, all that kind of stuff as well. So is an EV right for me? We'll start off with some more general material and then get into charging electric vehicles. and some forward-looking things as well. Okay, so let's start with a poll. So you should have a little window pop up on your screen in a sec. So we're asking about the running costs, electricity versus petrol. So how much cheaper is it to run an electric vehicle on electricity compared to running a petrol car? So you've got choices there you can click on, nominating 12% cheaper, 35, 70, or 90% cheaper. And then I'll jump in and share the results and to talk about which of those is the closest to the mark, I guess. All right, we've already had 24 people jump in. I might just give a couple more seconds and then we'll end the poll and share the results. Okay, so hopefully you can see on your screen now the results. So we've had a mix there, clustered around the 70% cheaper option, and that is officially the option which is nominated as correct for this poll, but that was done a little while ago, prior to the recent jump up in the petrol and diesel price. So it's probably closer to 90% now than 70. So that's everyone can make their own call, I guess, as to whether that jump is going to continue into the future. But yeah, either way, it's a pretty big saving on fuel costs if you're running an EV. All right, I'm going to click stop sharing. You may just have to click the little X at the top of that poll window to take it away from in front of your presentation. So why are electric vehicles so great? Well, electric motors have an instant response. So they can actually be very powerful, able to tow. As you can see in the bottom left there, we have an electric vehicle towing a jumbo jet. We've got electric vehicle motorsports, so Formula E in the bottom right, and then a off-road version as well. So yeah, it is a pretty awesome technology. However, what's going to make a real difference in the world isn't so much those high-end, like niche sort of markets. It's more the mass market. So once we start seeing a real uptake across the community, that's where we'll be seeing a difference. So why do we want to move to electric vehicles? Well, emissions is one. So with a petrol or diesel car, you're burning a fossil fuel. Your exhaust pipe is emitting carbon dioxide as well as other greenhouse gases. Your exhaust pipe is also emitting local pollutants like particulates and other pollutants that do actually have an impact on local health, respiratory diseases, that type of stuff. So that's another one to consider. And then fuel security as well. So with Australia, like 90% of our fuels are imported from overseas, either as petrol or diesel or as crude oil, which we then refine in Australia. So that supply chain is fairly vulnerable to disruption in the event of any kind of international conflict. So from a fuel security point of view, electric vehicles run on electricity that we can generate in Australia. So looking at emissions, so transport is nearly 20% of Australia's greenhouse gas emissions, and that's increased by almost 2/3 since 1990. So it's becoming more important over time, more of an impact in the mix of our emissions. And Australia is not particularly good at transport efficiency. So this is the an organisation that does a transport energy efficiency scorecard across different countries. And it's showing India at the top, Italy, Japan, and you have to go down to 22nd place to find Australia, just ahead of Saudi Arabia. So as an example of that, most developed countries have fuel efficiency standards. So so a country would say, okay, car company, take Toyota for an example. Yes, you're going to sell a range of vehicles in our country. We understand that. Yes, you can sell your big gas guzzling diesel 4-wheel drives. However, you have to balance that out with selling some really efficient cars as well. So your overall efficiency of your fleet of cars that you sell as a manufacturer in our country meets a minimum threshold for efficiency. Unfortunately, Australia doesn't have anything like that, and that's one of the reasons why we're ranking so low on the tables. Electric vehicles. So here's a chart showing the numbers of electric vehicles, and yeah, it's a bit of an exponential curve there, growing quite fast, which is good. China is yeah, a major player, as well as Europe and the US. However, when you look at it as a percentage of market share, it's still quite small. So the global average there in green, 4.2% of new car sales are electric. This is back in 2020. Some countries are actually already doing very high proportions of electric vehicle sales. So Norway's 3/4 of new car sales are electric. And yeah, then it goes, the UK's 10%. I think more recent stats still are similar to that. And in comparison, Australia is down at under 1% of new car sales being electric. Okay, so why is the uptake slow in Australia? What are some of the barriers? Well, there are some perception barriers. So previously, people might have been concerned that electric vehicles don't have enough power, enough, torque and power to meet their needs. Well, actually, electric vehicles include very powerful models. Range and charges, that can lead to some concern, but as I'll be showing you in the slides later on, for most buyers, that's not a real barrier. It's more of a perception. Now, a lot of car dealers are still pretty clueless about electric vehicles, and anecdotally, we hear a lot of cases where the car salespeople in the dealers are actually trying to steer customers away from electric and towards petrol and diesel. But this is going to change over time. Now, availability, this is a real barrier. There's not that many coming into Australia. They're just coming in as a sort of drip feed, and yes, the upfront cost is a barrier as well. And then questions about government policies, mileage taxes, that sort of thing. So looking at the New South Wales state government, it's aiming for half of new vehicle sales to be electric by 2030. Now, that does not mean that in 2030, if you look out on the roads, half of all the cars will be electric, and because there's that big mass of older vehicles. So even though half of the new sales might be electric, it would only be a minority of cars on the road that were electric in 2030. They're providing a purchase subsidy of $3,000. There are some limits to that. It's only for a certain number of cars. The stamp duty is being waived for EVs. They're investing in the charging network, and they've flagged ahead of time. So in 2027, there will be a state distance tax for electric vehicles of 2.5 cents per kilometre. So for an average sort of driving distance, that would cost about $300 per year. So that's good that they haven't brought it in immediately. There is one other state which actually did decide to bring it in immediately, which seems a little silly. Okay, so changes in the EV market. If we look at the table on the right there, there's a bunch of countries that have a stated policy of ceasing the sale of fossil fuel cars. So got quite a few around 2030 through to 2040 for the whole of the USA. Japan 2035, California 2035. So that sent a really clear signal to the automotive manufacturers, the car makers, that they need to switch over, and that's what they're doing. They're retooling factories from petrol and diesel over to electric vehicles. Research and development of petrol and diesel has basically stopped, and they're even building battery factories to create the battery capacity to supply their cars, and even going further up the supply chain to try and secure supplies of raw materials for batteries. However, at this stage, the capacity is still low. The factories are not tooled up sufficiently to produce enough electric vehicles to meet the demand. And with the small capacity that they have, the car manufacturers, if they've got a choice, well, I could send some electric vehicles to Australia, or I could send them to Europe, for example. Europe does have those fuel efficiency standards. So if they're not sending electric vehicles to Europe, then the car manufacturers are likely to pay quite high penalties. So that's a big reason why we're only getting a drip feed. The car companies have incurred high costs and are incurring high costs in revamping their supply chains. So that's one of the reasons why their electric vehicles are relatively expensive, because they're trying to recoup some of those costs. And when they do have a limited capacity to manufacture vehicles, then they're prioritizing their higher end models, the more sort of luxury cars. So as time goes on, we expect to see electric vehicles come in higher quantities and spread throughout the model range down to more sort of standard models as well as the higher end models. Okay, so if we look at a timeline from the 2010s through to the 2040s, so initially electric vehicles were the realm of enthusiasts. So people putting together their own EVs or converting petrol cars into EVs. Then there was the prestige market, where you had these sort of exotic electric vehicles that would really stand out in the crowd. Now we're seeing a lot of uptake by people who have long commutes, for example. So if with an electric vehicle, you're paying more upfront, but the running costs are lower. So if you're driving a lot every day, then those savings really add up for you. Commercial markets, multi-car households. So if you've still got, say, an old petrol or diesel car as well as an electric vehicle, then that gives you a lot of flexibility. If you are doing a really long country drive and you're concerned about range, then you've still got the ability to do that with your old car. And then as time goes on, we'll see uptake more in single car households. And then probably the hardest ones would be, for example, if you got a tradesperson in the country driving around in between jobs all day, with towing a heavy trailer with lots of tools, that would probably be the most challenging scenario for an electric vehicle. So we'd see them transitioning later on in the time frame, and maybe even the potential for biofuel or hydrogen, which I hope to mention towards the end of the presentation. But for a lot of EVs that don't have quite such long distances, for a lot of tradies, yeah, electric vehicles are a great option. Okay, so what sort of a future do we actually want? So at the moment, we've got 20 million fossil cars and doing around 250 billion kilometers a year just in Australia. The numbers really add up. So do we just want a straight swap and still have that number of cars and kilometers just on electric? Or do we want a more diverse future with different modes of transport, as our council representatives mentioned as well? And yeah, at the AEF, we would advocate for that more diverse option. So just to give you an idea of the costs, economics, I've just selected two specific models that have similar capabilities, similar size, etc. And so the electric vehicle model, you're looking at about $45,000 to $50,000, and your running costs are $285 a year. Servicing pretty cheap. With electric vehicles, you've got nowhere near as many moving parts as you do in a petrol engine. The drivetrain is pretty much just a battery and a motor. You don't have much else. Compared to the petrol car, where you've got radiators and oil changes that need to be done, and exhaust systems, gearboxes, etc. So yeah, the servicing can be quite a lot cheaper. With the petrol example, now I put these numbers together prior to that big jump up in petrol prices, but at that stage it was about $1,200 per year. So that would be higher now. So that gives you an idea. And the petrol vehicle, you're looking at $25,000 to $30,000. So yeah, so yes, at the moment there is a fairly high price disparity going electric compared to petrol for that upfront price. Now, looking at going a bit broader than just cars, so let's look at how much energy it actually takes to travel 100 kilometers. So an electric bicycle, you're looking at about 1.2 kilowatt hours of energy that you'd need to use to travel that far. An electric train is a bit more. Electric motorbike is up to 9.3. An electric car, a standard sort of passenger vehicle, 14.3. And then a petrol sedan, the amount of energy is up to 54. So you can see the massive jump there between the efficient electric options and the internal combustion. And the main reason for that is the energy content of your petrol fuel. Most of that energy is actually wasted by the car. So that's why they have a radiator at the front, is to safely get rid of all that wasted energy in the form of heat. Another reason is that with electric vehicles, when you take your foot off the accelerator, the car slows down, and that's not because the friction brake is being applied on the wheels. It automatically puts the motor into like a reverse. So instead of the motor driving the wheels drive the motor, which becomes a battery charger, and it's charging up the battery. So the car's slowing down, and you're putting more energy back into the battery, which really helps with the efficiency. Now, from an emissions point of view, this is an analysis, some results that I found from Europe. I couldn't find a similar one in Australia. So in Australia, we have a government website called the Green Vehicle Guide, which is great. And you can use that to compare different models and see how the emissions compare. But that only looks at the driving emissions. So it looks at with a petrol car, you're burning the petrol. Okay, what do those emissions stack up as? With an electric car, you're using electricity, the majority of which is coming from burning fossil fuels at the moment. So how do those emissions stack up? And you can compare them. But going a step further than that, it's also good to look at the emissions involved in producing the cars. So that's what this study did. So on the left there, you can see the light blue down the bottom is the battery production for the electric car. Then we've got the car production. So, you know, the steel to make the body of the car and everything. And then we've got the grey one, which is the emissions over the lifespan of the car to drive it from electricity. And then on the right, we've got the petrol car. So it's got the dark blue bar to manufacture the car. And then we've got that big grey bar for driving the car over its lifespan. So yes, they found that the electric car was, the lifespan emissions were almost 2/3 lower than the petrol car, which is great. Resource use. So this is another thing you might think about. Okay, so an electric car uses this this battery, which is using resources that have to be mined. Well, here's just an interesting comparison. So if we look at this green battery in the person's hand there, it's the size of battery that gets used in laptop batteries, you know, the battery packs in a laptop computer. Gets used in torches as well and other things. And it also happens to be used in some electric vehicles. So 7,000 of them go into this model of electric vehicle down the bottom there. For comparison, only 50 of them are needed to go into the battery of this electric bicycle. So that gives you an idea of, yes, if you're looking at resource use, then something like an electric bicycle is, much kinder on the supplies of raw materials than an electric vehicle, for example. And then the petrol car over there would use about 800 of these jerry cans of fuel over a 20-year lifespan. And the other point is the batteries can be recycled at the end of their life. I've never heard of anyone recycling petrol after it's been burned. Okay, so speaking about the batteries a little more, you'd be familiar with your mobile phone battery. When the phone is new, maybe you can go for 2 days without recharging it. But then after some years, you find that you need to start charging the phone more and more frequently. The usable battery capacity is fading. It's declining over time. And that is true to an extent of electric vehicles as well, but they're actually, the batteries are a lot better than mobile phone batteries. They're bigger, they're engineered better, they've got a battery management system that regulates how they operate more closely. So you would expect to, say, after 250,000 kilometers, then the reduction in that usable capacity, it might be anywhere between 12% to 50%. It's hard to be definitive, but we do have examples now of electric vehicles which have done very long lifespans. Even in Australia, with there are electric vehicles that have been used as taxis and limousine type services that have racked up high numbers of kilometers and with minimal fade on the battery. Warranties are typically about 8 years on the battery. And what are the prospects that you might be able to replace a battery at some distant point in the future when it needs replacing? Well, probably pretty good, because we have a precedent. There's an electric vehicle that was sold 10, 12 years ago called the Mitsubishi i-MiEV. AEF actually had one of those for quite a few years. And if you have one of those vehicles that would now be like 11, 12 years old, yes, it is possible in Australia to have that battery replaced. And the cost for that at the moment is around $13,000. So that might give you a guide to how much a battery replacement might cost. But bear in mind that if your battery is only going to be replaced in the 2030s or end of the 2030s or something, then we would expect battery prices to have dramatically dropped by then. So it shouldn't be anywhere near as much as the cost of a battery going into a car now. Okay, so if you've got an electric vehicle, it's a good idea to be kind to the battery, and give it an easy life if you can. So what does that mean? That means try not to leave the car parked for, days and days in extreme heat, like, 40+ degrees. And also try not to leave it parked for days and days when it's 100% full or down near empty, because those are both conditions that are not so kind on the battery. So it's better to, if you're going to leave it parked for quite a while, then like days, then just leave it somewhere sort of half full, or just not right at the top or right at the bottom. And yeah, fast chargers on the highways, the ones where you can really charge up the battery fast. That's, yeah, not. I mean, it's fine, but if you wanted to get the ultimate lifespan out of your car, then you'd try and use that as an exception rather than your everyday mode of charging. Yes, electric vehicle batteries can be recycled. There are already some facilities in Australia that can do it. It's looking to be a big market in the future, once that stream of electric vehicles starts to wear out. But there's also an option to reuse the batteries. So they can be used for storing solar power from the middle of the day and discharging at night, for example. Second-hand electric vehicles, there are several sources, including a link down the bottom of the page. So this is going to become a pretty important channel, especially with fleets. So I think around half of new car sales in Australia are actually bought by government fleets, rental car fleets, government leasing fleets. So the cars provided as part of salary packaging, etc. And they tend to turn over their cars, I think, between 3 years and 7 years. So if we can get a big uptake in those fleets, then a handful of years in the future, we'll have a good stream of electric vehicles coming onto the second-hand market, which will provide a much more affordable source of EVs. Okay, so let's move on to charging. So some drivers sort of have the mindset of, if they get an electric vehicle, then the way to charge it is to go out and find a fast charger on the highway somewhere. But actually, 90% of electric vehicle charging at the moment is done at people's homes. So think of it more like charging a mobile phone. You can plug it in every night, or opportunistically, if you're home for a while, just plug it in, and at other locations away from home as well, which I'll come to. So almost all electric vehicles come supplied with a portable charger, otherwise called a trickle charger or a granny charger. So this is the most flexible option to charge your car, but because you can plug it into any standard 3-pin power point, and then the other end of the cable has a special plug that you put into your electric vehicle. So that just works at pretty much the maximum power that a standard power point can provide, and yeah, that's a pretty good option. The next level up is a fixed charger or wall charger, as you see in the picture there. So that's giving about 3 times the power level of the portable charger. Would you need to go up to that level? Well, it depends. If you're just doing a 40-kilometer average drive every day, then maybe not. You can just plug in overnight with a portable charger, and in the morning it'll be full. Where you might need to step up would be if you had multiple electric vehicles, or if you had cases where you're doing a quick turnaround, like you've done a long country drive during the day, you're just home for dinner and a shower, and then you're turning around and doing a long drive at night as well, then if you really want to get some charge into the car at home in a short space of time, then yes, that would be another example where you might want like one of these fixed charges. So other options, supermarkets and council facilities and street parking, as we've heard from our council representatives today. And some of those are actually free, you can find. I'm not sure what the plans are with the inner city, inner west council, but yeah, I guess we'll see. The free ones are becoming less likely now as the market matures. Most of them you do have to pay, and the way that you pay is, like most things these days, is through an app on your mobile phone. So you can sign up to one of the charging companies. So ChargeFox and EV are the two biggest ones. So you create an account with them, you provide your credit card details. So then when you turn up to one of their chargers, you plug in, and on your phone usually you're providing the authorization for the ID of that specific charger, and it'll charge your credit card. So it's pretty simple to do. The Tesla charging network is even simpler because it's using your car as the credentials. So you don't even have to worry. You just plug it in and it just charges, and automatically, yeah, you'll pay for that through your credit card. There's a great website to find chargers, so that's plugshare.com. So what that does is you've got a map that you can pull up, and little icons of chargers that you can click on, get information about the chargers, and really usefully, there's even a space where previous users have left some notes. So they might say, oh, it's around the back of the car park on the right, or they might have some notes about how easy it was to use and that type of thing. So, and what sort of car they were driving too. So that can help give you some confidence. Oh yes, and some of these chargers that they don't have a cable built into the charger. So to take advantage of those, you actually need a cable that you have in your boot of your car, which is like a double end electric vehicle. So it's got the same plug on both ends, but so you're plugging that in at the wall charger. Okay, so highway chargers. So these are more the size of like petrol Bowsers, as you can see in the picture. And here we're looking at around 7 times as fast as a wall charger. So what's 7.3? So like 20 times as fast as a PowerPoint. And some of them even go faster than that if your car has the ability to take advantage of that speed as well. So one thing to be aware of though is that as your car is approaching the battery being full, then the rate of charging will slow down a bit. It's a bit like if you're pouring a jug of water into a glass, then you'll start off pouring fast, and then at the end you'll slow down. So nice etiquette for other electric vehicle users who may potentially be waiting is if you're on the highway and you don't need that extra little bit of range right at the top of your battery capacity, then yeah, just charge up to 80% or so, and that way you can get back on the road more quickly rather than waiting for that slow charge at the end. So average travel distances. So 90% of daily vehicle commutes are less than 40 kilometers. So that's in Sydney. And electric vehicles, the modern ones, most of them, almost all of them have a range that's 300 kilometers or more. So you can see that if you're doing just standard daily driving, then range is not even a problem. You don't have to charge even every day. You can just charge, you know, once or twice a week sort of thing. And there are some electric vehicles that have really good ranges, even higher than that. The map here is the New South Wales state government, their electric vehicle superhighways. They're rolling out a whole bunch of electric fast chargers. Yeah, you can see all the points there on the map. So finding a charger, I already mentioned PlugShare, also transport.newsouthwales.gov.au. Onboard navigation systems in electric vehicles, yes, and even Google Maps. So there are plenty of ways to find them. Okay, so how much is it likely to cost to charge an electric vehicle? Well, if we just look at household charging, so a standard household might consume around 18 kilowatt hours of energy daily, electricity from the grid. So with one electric vehicle doing, say, 40 kilometers, then that would translate to about 8 kilowatt hours of electricity per day. So each 5 kilometers might use 1 kilowatt hour of electrical energy. So yeah, one car, it might increase your household electricity consumption by half. Now that sounds pretty bad, right? Like, aren't we trying to reduce our energy consumption? Well, yes, but in this case, it's actually a good thing, because yes, you're increasing your electricity consumption, but you're reducing your petrol consumption, like down to zero if you're going from a petrol car to a electric car, and that ends up with a much better, yeah, works out much more economical to run an electric car than a petrol car. So the plug for charging, on the bottom left there is a picture of an electric vehicle with the charging hatch open, and you can see the socket there. So the normal plug plugs into the top part of that socket, and there's also a fast charge plug which goes in the same place, but it's going into the top part and the bottom part of the socket as well. So the normal plug uses these power pins at the bottom here. The fast charge plug has these big fat power pins, which is why it can charge faster. And these control pins up the top here, they do what's called a handshake between the car and the charger, not a physical vibration, but like an electrical communication. So for example, worst case scenario, you're about to plug the plug into your car, and you accidentally drop it and it falls into a deep puddle. You don't have to worry about electricity and water, because these power pins are not activated. They're not live until these control pins have made contact in the car first. So that's the sort of thing that's going on with that handshake procedure. It's all automatic. You just plug it in and it works. It also, you might notice this little square slot at the top of the charger. That's for a physical lock. So while the plug is plugged in, the car also locks it until you unlock it, usually by just pressing the unlock button on your car key. Unlock the car door, and that will automatically unlock the charger lock as well. So that's just to avoid some curious onlooker passerby from just unplugging it. So how does the power flows work? Okay, so let's talk first about the standard plug here, which is included on your portable charger. So this is the most flexible option. You can plug it into any standard power point. And the reason why that works, why it's so flexible, is because it uses this onboard charger, which is included in all electric cars. And what that does is your standard power point electricity is going through your portable charger, through the onboard charger, and that converts it into the electricity that the battery needs, which is direct current, DC. So that's great, but it is limited in its power, because if you want faster rates, then you need a bigger charger, which you don't want to be lugging around a massive charger, taking up space and weight in your car. So that's why these big highway chargers, the big tall ones, they're doing that function in the charger itself, of converting the standard electricity, 240 volts AC, into the electricity the battery needs, and then supplying that directly into the battery by bypassing the car's onboard charger. So that's why they can reach higher charging speeds, because they can exceed that charging speed limit which the onboard charger has. So if everybody plugs in their car, if everybody comes home at 7 p.m. and all plugs their cars in at the same time, is it going to melt the grid? Well, if everybody did that, then that actually could be a problem. So really the important thing is that as we get higher numbers of electric vehicle chargers, that most of them at least are smart enough to avoid charging at full speed during those peak times in the evenings. Now, most of the time, networks actually do have plenty of spare capacity already, to accommodate electric vehicle charging. The only time that they get tight is when you have a peak event like a heat wave, when everybody's got their air conditioners running as well as their cooktops and TVs and everything else. So just as long as the chargers are smart enough to not go at full power during those peak events, then the network will be okay. And yeah, EVs are not going to everyone's not going to switch to an EV tomorrow. It's going to take quite a bit of time for that to happen. So the grid does have a chance to adapt, which is good. How about the energy to charge up all of these electric vehicles? Where's it going to come from? So I did a basic analysis on this, and yeah, it looks like if you look at how much electricity goes through our electricity grid at the moment, like around Australia, if everyone switched over their petrol cars to electric vehicles, that might increase by 20%. So yeah, that's a fair bit, but it's definitely doable. So 1,800 wind turbines could supply that much energy on an annual average basis. Rooftop solar, if we ramp that up to 1.88 times the 2020 level of rooftop solar, that could do it. So yeah, over a gradual uptake of electric vehicles, that's definitely doable. And the other point is that if everybody doesn't go from petrol car to electric car, if some people use other transport options like electric bicycles, public transport, active transport, then that equation becomes even easier to achieve. So let's say you've got rooftop solar on your house and you're keen to charge directly from that as much as possible. So the way to achieve that is with a solar aware charger, like a wall charger that knows what your solar system is doing. And the main one that exists in Australia is called a Zappi, and it doesn't cost that much more than a standard sort of dumb wall charger, and it has a sensor in your meter box, so it knows when you're exporting power to the grid, and it knows when you're importing from the grid. So let's say you're exporting 2 kilowatts of power because it's a nice sunny day and you don't have many appliances on. You're exporting, then it will charge up your car at that power level. So it's soaking up all of that excess, but it's not charging higher, which would need electricity to come from the grid to supplement it. If a cloud comes over and you're not exporting power anymore, then it'll pause its charging until the sun comes out again. So that makes pretty good sense. And it still has the ability for you to come and say, okay, I just want, I need to get some power into the car pretty fast. So you push a button and yeah, ignore what the solar's doing, just charge up at full speed. There are some other options for this. I'm aware that Tesla has a Tesla specific product, which where the Tesla car is connected to the internet, and the internet is connected to the solar system on your house, so they can do it that way with the car actually controlling the charger level. So we'll probably see more options coming out in the future. So if you want to future-proof your home for electric vehicles, well, you in the future you might be looking at other things as well. So it's now, as a general rule, it's now more economic for a home to migrate away from gas appliances as they wear out over to efficient electric appliances for heating, hot water, cooking. So that's something to think about. If you're going to be staying in your home for quite a while, then you work out a bit of a plan for what you're going to be doing with your electric appliances. And if your switchboard looks a bit like this, where it's full of safety switches and you don't have, you know, more space to add new safety switches, circuit breakers at the end of your row, then you probably need to think about having an electrician upgrade your switchboard at some point to a bigger one. For example, instead of having a single row of switches, a bigger one that has 2 rows there. We've got a bunch of resources for you as well at AEF and also from the Electric Vehicle Council. So you can have a look at these. And the Australian Electric Vehicle Association, they've got some really good resources on all the different models. We haven't got time to go into them in this presentation, but yeah, there's a bunch of different EV models out there for you to choose from. So part 3 of the presentation is what to look forward to. So here's a cute picture from a electric vehicle advertisement. So this is a car which is parked out in the middle of nowhere. So the same port at which you put the plug in to charge the car actually comes with a little gadget that you plug into the same port, and on the back of it is a standard PowerPoint plug. So you can run any appliance off your car. So it's running off the car battery. And in this case, they've brought a fridge out here for some reason. So this is called vehicle to load. That's the sort of jargon for that, running appliances off your car. Now, two-way power. So this is mostly the same diagram I showed you last time. So if you want to run, okay, so vehicle to load, running an appliance, that's available now. But if you want to run your whole house, that's not really available at the moment. It's this standard plug, it has to use a standard for communicating between the charger and the car. And that standard at the moment does not support two-way power. But the new version is expected to support it in 2025. So that's a few years away. So if you, in a few years' time, if you get a new car and you get a new wall charger, then you should have pretty much everything you need to run your house off your car. You would need a bit of electrical work just to make it all communicate with each other. And if you wanted to run your house off your car in a blackout, then the electrician also needs to install a switch to disconnect your house from the grid. So otherwise, if you're running your house from your car, you might actually be trying to run all your neighbors off your car as well, and that might not work out too well. So that actually becomes a pretty compelling option for a solar battery. So if you're getting a solar battery, the models available now, you might be paying $10,000 or more just to add on the battery onto your solar system. But if you're getting the electric car and the wall charger anyway, then while the car's at home at least, then you might have a battery that's like 4 to 6 times the capacity of a solar battery. And yeah, you've pretty much got that capability for free. So that's a useful option to think of. Now some of you are probably thinking, hang on, why is Andrew saying that this is not available now? I've heard of cars that can do it, and I've heard of trials that are being done in Canberra. Yes, they are being done, but only with this other type of plug. And the downsides of this plug is it's basically obsolete in Australia. Any new car that you buy now is going to have the normal plug. And the other downside is it's going direct into the battery. It's not making use of your car's onboard charger. So your wall charger has to do that function of converting from AC to DC. So you're looking at a much more expensive wall charger than the standard ones I've been showing you before. So it may be possible, but to all practical purposes, we're really a few years off. So vehicle to home, this is what I've been talking about. Yeah, one point here is Volkswagen have come out and said that cars being sold in 2022 their onboard charger is already a two-way charger. So it should be easy to use those cars for two-way functions once the standard comes out in a few years. Unfortunately, Volkswagen aren't bringing any of their electric vehicles to Australia yet, hopefully next year. Okay, vehicle to grid is the next level. So if you've got your car plugged in at your house, then potentially your car battery, if you wanted it to, if you were incentivized, could provide some power to help out the grid when the grid needs some help. So the way I'm imagining this might work is you're a car electric vehicle owner. You get a text message from your electricity retailer, your power provider. A text message says, discharge 20% tonight and receive $20. Reply Y to opt in. So you think, okay, I'm not doing a long drive tomorrow. I don't really need that extra 20% capacity. So you reply Y on the text message. You plug your car in, you leave it plugged in overnight, and overnight your car discharges just a 20% of its battery capacity, and then the next time you get your bill, you get a line item there that says bonus $20 for vehicle to grid. So I don't see many downsides with that for an owner. And yeah, the potential, if we had say 5 million cars doing it, then that adds up to, in terms of energy storage capacity, around 300 times the South Australia Tesla big battery, the Hornsdale Power Reserve. It also adds up to almost 10% of the Snowy Hydro 2.0 pumped hydro scheme. So yeah, I think it's got a lot of potential. One possible concern is putting extra wear and tear on your car battery. I don't think it should be a practical issue, because if it's just being used for that occasional opt-in sort of usage, just when the grid really needs it, then that's not doing much on your battery, and it's only at a slow power level, compared to when you put your foot hard on the accelerator going up a hill. I mean, that's very easy on the battery. But yeah, you would want to check with your car warranty that's included. So hybrids and hydrogen. So hybrid car, it's got a petrol engine, plus it's got an electric motor and a small battery. So the advantage is that it's cheaper to buy than a pure electric vehicle. The downside is that the battery is getting worked harder. So relative to the size of the battery, of the battery, when you're running the car on the battery, it's taking a higher proportion of the battery's capacity out. And you don't get those servicing benefits of a full electric vehicle, because you still have to do all the servicing on all the petrol stuff, and also you've got the battery as well. There are two varieties of hybrid car. That there's the one that's most common in Australia. It's got no socket on the car for you to plug the electric vehicle charger into. So all of its energy is coming from petrol. So yeah, and the only purpose of the electric motor is to improve the efficiency of the car. So when you see advertisements that talk about self-charging hybrid, well, it really just means petrol charging. It's just running on petrol. The other variant is a plug-in hybrid, where it does have that port on the car where you can charge it up. So that gives you the possibility, if you're just doing, daily short trips, then every night you charge it up, and you don't even need to burn petrol. For short trips, you're just using it like a full electric vehicle. Now, hydrogen these cars are extremely rare. There was previously a fair bit of hype around hydrogen cars, how they might be a better option than electric vehicles, but I think everyone's now recognized that electric vehicles are the better option for almost everybody. The main reason is, well, where is the hydrogen coming from? To produce hydrogen, you can get it from water, but the amount of energy it takes to extract hydrogen from water is a lot more than the energy you get out the end when you burn the hydrogen, or consume the hydrogen. So you're going, okay, so where are you going to get the electricity to extract the hydrogen from the water? Well, hopefully you'd be using it from solar and wind, like renewable energy. So you're going electricity to hydrogen, and then back to electricity in the car. Because the hydrogen car, it is an electric car. It's what drives the wheels of an electric motor and a small battery. It's just that you've got this hydrogen tank, which is the battery for the battery. So the efficiency is pretty terrible. So you end up needing to use about 3 times as much electricity to drive 100 kilometers in a hydrogen car as what you do to drive 100 kilometers in an electric car. So use a lot more energy, which means it's going to be at least 3 times as expensive to run, and the cars themselves are very expensive too. So the only real advantage is that, yes, you can fuel it up quickly. So you're putting a more normal sort of Bowser, like a petrol or a LPG, to fill up your tank of hydrogen in the car. So yeah, quick fueling and range is the only advantage, but with the speed of highway fast chargers these days, and the expanding availability of charging, yeah, it's looks there's only a very small niche for hydrogen cars. Okay, so the key takeaways from our webinar tonight: cheaper electric vehicles are coming. So yeah, there are some Chinese models. There's already one Chinese model at least out here. which is around the 40 to mid $40,000 level, and there are more models coming which should push the prices down below that, and yeah, hopefully a bunch of European cars as well. And yeah, electric vehicles, yes, they're part of a sustainable future. They're not the be all and end all. I mean, we do advocate for other sustainable transport options as well. And yeah, it's a good idea to plan ahead. Think about how an electric vehicle might fit into your life, into your electricity bills, in where you might fit a home charger into your property if you do have off-street parking. If not, then yeah, how you might charge up while you're at a supermarket or car parks or out on the highway as well. So just a few notes before we get into questions about how we can help with this at AEF. So yeah, we provide trusted independent advice, and yeah, we can connect you with suppliers as well to help you make that next step with quotes on a whole bunch of topics, from solar panels through to window film. You can get a free energy consultation because the local government area is a subscribing council with AEF. Then residents can call up as many times as you like our energy advisors and receive some free advice. Now, after the questions, just like you to know that you'll get a little pop-up window. That's actually our survey. So it does help us a lot if you could just give us some quick feedback on how you found our webinar. That would be great. All right. So let's jump over to questions. I'm sure Gus has been busily answering a lot in the background as I've been talking, but yeah, should I jump into the Q&A, Gus, or what do you think?
Yeah, that's okay. I can read them to you, and we can create a small panel here. So, just a quick thanks to everyone that has submitted questions. They've been absolutely brilliant. So yeah, I hope to provide some more elaborate detail on that now that we've got Andrew live. So there's a couple that have just popped in. I'll address those, and then maybe we can come to some of the other ones that I've provided a brief answer to. This one at the top here is, my house has 3-phase power. What is the implication of this regarding charges for EVs?
Yeah, good question. So a standard home has single-phase power, which is basically one active cable that's coming into your property. 3-phase power is a higher capacity connection into the electricity grid, and so that gives you 3 active cables that are coming in. So that gives you more flexibility with electric vehicle chargers. You can still install a standard electric vehicle charger like the ones I was showing in the pictures. So that's a power level of 7 kilowatts. That's single phase. So that would just be have a cable that just goes into your switchboard, just connecting to one of the active cables. So that's fine. You also have the option of installing a 3-phase electric vehicle wall charger. So that has 3 active cables coming from the wall charger into your switchboard, joining up to all 3 of your power phases. And that has the ability to charge a car up to 22 kilowatt hours. So potentially you could charge a car at home 3 times as fast as most people. The proviso there is if your car can actually accept a rate of charge that fast through its onboard charger, and most cars can't. So you'd have to check the specs. There are a few that can charge up at 22 kilowatts of power through the onboard charger, but a lot of them it's more like, well, some can only charge up at the same speed, like the as a single phase, like 7 kilowatts.
Mm.
Some are 11 or 15 kilowatts. So yeah, simple answer, yes, you've got the option to charge up faster, but just see what the car's actually capable of. Yeah.
Again, another good point there is just probably around battery longevity. And if you can drip charge overnight, it's probably going to do the world of good for how your battery's lifespan.
Yeah, that's true. And even if you do have like a 3-phase wall charger that can do 22 kilowatts, yeah, there'll be a setting either on the charger or on the car where you can instruct it to charge at a slower speed. So yeah, you could have like a normal setting and then a sort of, okay, just fill me up ASAP setting. Oh,
Yeah.
and while we're on the topic of 3-phase, I think we've got time to elaborate a little bit. It's got other advantages as well. So for solar, for example, if you want to put a large solar system on your roof, then 3-phase is an advantage, because Ausgrid, the poles and wires company in the area, they normally only allow a power limit of exporting around 5 kilowatts on a single phase back to the grid. If you've got 3-phase, they'll allow you to export up to 15 kilowatts of power out to the grid, 3 times as much. So that's helpful for putting on big solar systems. Like it's more headroom to send power back to the grid and earn a bit of money for that. And it also has some other benefits for avoiding bottlenecks and choke points as the power goes out. So yeah, look, if you're on single phase at the moment, like as most households are, and you are looking at maybe getting electric vehicle charger, maybe converting gas appliances over to electric, then yeah, 3-phase is worth considering to have that higher capability. Yeah.
It's a really good clarification there, particularly in the knowledge that solar and EV charging will really go hand in hand as they become more popular. This one is quite a good question here, and I'm sure there's a lot of people in the inner west that have a similar thing on their minds. And so before I jump into this one, I might actually just quickly mention as well, this is the moment where I can say, type now or forever hold your keyboard. Definitely pop your questions in now if you have any curiosities. We've certainly got a little bit of time left that we can answer these, so go for gold. So this one is from Susan McFarlane. How will home charging work in blocks of units, particularly older blocks?
And I see she's just put a follow-up specifically for underground car parks. Yeah. Yep. Very good question. So it's not an easy one to answer, because as anything with owners corporations and body corporates, it can get tricky. So yes, you'll have to work through your owners corporation to get things happening. There are different levels you can do it. So the lowest level is just to put even just a standard PowerPoint available in the visitor parking in your underground car park. So you might just have a couple of these, and so then someone can plug their car in and just at least get a bit of a trickle charge happening. Obviously, that's not going to cut it if a significant proportion of the residents are upgrading to electric vehicles. They'll be fighting over the visitor spot. So then there are higher levels where you can install like these wall charger type units, or even just PowerPoints on all of the car parks that are allocated to residents. So obviously that has questions for how the cables are going to be put through, and the power supply capability of the building as well. And there are some clever systems it's quite normal now in apartment blocks and shopping centers and things. So the car charging system can allocate out the available power. So if you only have one car charging at a point in time, then it can have all the power. If you got 10 cars charging, then they all just get 1/10 of the power. So yeah, there are ways to make it work pretty effectively. But yeah, you'll need to work through those issues of getting approval through the owners corporation and quotes from suppliers to do the work and all that stuff. And there's actually a really good webinar that a recording is available with Randwick Council. So maybe we can find that and include a link to that from our follow-up email, where they had a panel of experts that were talking specifically on this issue. So yeah, I'd recommend having a look at that one.
Great answer there, Andrew. Thank you. There's a few more that have come in, so thanks to all who are typing madly away. Let's get some rapid response going. So, will it cost more if you can't charge at home, i.e., no off-street parking?
Yeah, there's a few places that are generous, like some of the council charges and things where it's free, but I think that's a historical now. So yeah, normally it does cost more. So, but still a lot cheaper than petrol, basically.
Okay. This one here is from John Oakley. You mentioned the EV batteries last around 8 years. But what I heard a so-called expert on the radio say is that the Nissan Leaf battery only lasts 2 years and is non-replaceable. Is this true or false? And also, what brand batteries do last 8 years?
Well, I'm really skeptical about someone saying a Nissan Leaf battery only lasts 2 years, because there are heaps of people with Nissan Leafs from like 10 years ago that are still going on the batteries. Yes, their capacity has faded, and especially since batteries that came out like 10 years ago with the original Nissan Leaf cars, that was an earlier generation of battery technology. So you would expect that they would fade more than cars which are coming out today. But no, they lasted a lot more than 2 years, and they actually are replaceable. There's people especially in Europe that are replacing Nissan Leaf batteries. Yeah, the host of the Fully Charged website has done it himself. So yeah, they are replaceable. One issue with the early Nissan Leafs was their battery management systems were not as good as the cars available today, specifically with cooling. So if you did have an older Nissan Leaf and you were leaving it fully charged in 40-degree temperatures, then yeah, that was pretty harsh on their battery, or even charging up at fast chargers. So the follow-up question was which batteries last 8 years or more? Well, I'd be looking at cars which have a good track record of battery research and development. So Tesla are clearly leaders in that area. BYD, it's a big Chinese company that makes batteries and cars. They're a huge battery manufacturer. So yeah, just do a bit of research on what battery is used in the car and what sort of pedigree it has. I think if it's if it's hard to find that answer and you're not sure what type of battery is in the car, then you have less confidence, I guess.
That's really good advice. Yeah, and I think synonymous with anything like being an early adopter is certainly do the reading and make sure you're across the detail, which is why we're hosting these sessions. So we hope it's been useful. There's a few more questions in here regarding three-phase. So I might touch on them. It seems like there's some curiosity around that before just addressing one of the final ones here. So I guess I'll try and put this into two-pronged question. So I guess, what does it cost to convert from single-phase to three-phase? And also, I guess, what are the difficulties or what is the process to upgrading to three-phase for residential? Residential property.
Yep. Okay. So there's kind of two components to the process of upgrading. Your electrician needs to upgrade your switchboard. So it's now like it can accept those 3 active cables, and your different circuits, your different appliances in your house are split up in between those 3 active cables. And also Ausgrid will have to do a truck visit to upgrade the actual cable from the poles and wires to your home. So cost for the electrical work by your electrician, maybe $700 to $1,000 or a bit more, that sort of level. And then the Ausgrid truck visit, I'm not sure, but it shouldn't be as much as the electrical work. Yeah, and so it's not particularly hard to do. It's just just need an electrician to help you do it and to organize the process with Ausgrid as well. Yeah.
Great answer. Okay, so this one is, I guess, more in line with, what charging options will people have available to them? We're presenting tonight to the Inner West. The amount of parking spaces that are off street are going to be, quite limited. So if you could just make some comments around, I guess, what are the facilities going to be like? What can people expect that don't have off-street parking?
Yeah. Well, I guess one of the good things about Australia being such a lagging so far behind with electric vehicles is we can look to other countries and see what's happening. So there are supermarkets in China where like every car park in the supermarket has an electric vehicle charger, every parking spot. So I'd expect more of that to be happening, and shopping centers and wineries and all sorts of businesses are going to use this as a point of differentiation to try and attract customers. So I think that's going to become a bit of a default option. Is you're going to the movies, or you're doing your weekly grocery shopping, or hanging out at the shopping center, and your car's charging at the same time. I think that's going to be a pretty big portion of the charging for people without off-street parking. And then on top of that, you have the highway charges as well. So if you are doing a long drive, or even if you're not, even if you have to stop off once a week just to put a bit of extra juice in the car, then that's not going to be too bad.
Awesome. Yeah, looking forward to seeing that more synonymous in the area. Certainly in the inner city areas, I think that's going to be happening quite quickly, particular to what Inner West have updated us with tonight on what their plans are there. This one, Andrew, is actually my own curiosity. I just want to throw this one in just to elaborate, I guess, because I think we may have only touched on this briefly in the presentation. But what are the options for recycling batteries? And if people are looking to replace their batteries, if you don't mind just adding some more info there on what that looks like, cost, etc.
Right. So if they're buying a car now and then perhaps replacing their battery sometime in the late 2030s or mid 2030s or something. Yeah. Okay. Well, yeah, that's a bit of a crystal ball sort of exercise there, but I think the fact that we do have precedents happening now is really encouraging. So I would expect that, yes, battery replacements will become fairly normal in the mid 2030s. If you've got your ancient Tesla Model 3 or something, then and you work the battery hard, and the range isn't meeting your desires anymore, then yeah, you'd be able to take it to a facility, a business that specializes in replacing batteries, and they would say, yes, well, yeah, you had your old 2023 battery that, you know, only gave you a range of 400 kilometers. Well, I've got this new battery which gives you a range of 600 kilometers, and you know, it's half the size, and it only costs you hopefully not too much. So yeah, I assuming that we progress on a technological pathway, then yeah, I think that'll be a pretty normal option. And even if you do have to pay a bit to replace your car battery in, you know, 10, 15 years in the future, if you weigh that up against all of the, you know, mufflers and oil changes and all those other things that you would have had to have had replaced, fuel filters, air filters, it probably works out as a pretty good comparison.
Absolutely, and I think the other thing there is the economy is, you know, it's an economy of scale, and once the demand is there, much in the same way that we've seen with solar, you know, that the price is driven down. You know, we have solar recycling available, yeah, and there are many more providers out there, you know, that are there to service those needs. So I think all good things to look forward to. We have one more, and then I think we might wrap if there are no others that are going to come in. So this one is one from Susan McFarlane. Quite an interesting one. I know my parents are thinking about this, so I'd be interested to know what sort of options there might be here. How will EVs work in the bush when one is off grid?
Okay, well, if it's an off-grid property, like a household or a cattle station or something, then normally they have an electricity off-grid electricity system at the house, which runs on normal 240 volt AC household electricity. So yes, you can just plug into a PowerPoint or install a wall charger as you would with a house in the suburbs. Yeah, the only proviso there is that if you're charging up your car in a cloudy winter week when the batteries are a bit low on your house, then that's putting a bit of a strain on the batteries. But most of these properties actually have a generator as well. So in those sort of rare conditions, then yeah, the house batteries would be topped up by your petrol or diesel generator. So yeah, you may end up effectively charging your car with a bit of petrol or diesel. Yeah, if you're talking about a camping type situation, then actually you're in a better position with an electric vehicle than with a petrol one, because it's possible to have a well, there are some cars that actually have a solar panel integrated into the roof. So those will enable you to add a bit of charge into your car every day. Not heaps, but if you're camped out in the sun for a week, then that would be pretty significant. So yeah.
The point there is redundancy. You know, always build in redundancy. I might bring council back to give us a sign off, but thank you for all the wonderful questions. Hope those are answered for you, you know, in a satisfying way. If you would like more information, of course, or any other questions that you'd like answered, don't hesitate to get in touch with the AEF, and we're more than happy to help out. Over to Kribo and Ken for signing off.
Thank you so much, Gus, and thank you, Andrew, for that amazing presentation. I learned so much tonight, and thank you to both of you for answering all those questions, and for Ken, who hopped in there a couple of times as well. Yeah, that was fantastic. Ken, did you want to say anything?
I'd just like to reflect your comments Gus, Andrew, thank you for a great presentation. Thank you all the participants for being involved, and please keep your eye out for our electric vehicle encouragement strategy exhibition in July. I really want to get some feedback and see where you want them, what you want done with them, so that we can start prioritising our actions.
Yeah,
Thanks
fantastic,
all.
Ken. Yeah, that's great. And yes, thank you everybody for attending. And when you leave, there will be a survey that pops up. So don't just go, oh, pop up and close it down, but perhaps answer the questions. And look out for an email from us. It probably won't be tomorrow actually, because I'm in training, but in the next few days. And check out your spam if you don't see an obvious email coming through from the Green Living Centre. So thank you, everybody, and yeah, enjoy the rest of your evening. It was yeah, really great to have you all here.
Thank you so much. Have a wonderful night, everyone.
See ya.
Thanks all. Cheers.
Bye.